going through this warm-up. Today you might want a lot of different colors of like highlighters, markers, some sort of something. Okay, what was the perimeter when you increase by a scale factor of 2? 32 what? Units. What was the perimeter when you increase by a factor of 3?
48.
What was it? 48 units. Okay, what about an area increased by a scale factor of 2? 60 units squared. Increased by a scale factor of 3?
135.
Yes.
If we're using the rectangular prism one, we can use inches there.
Oh, perfect. Good job. Yes, this should just be inches. Instead of U, should be inches. Okay, volume increased by a factor of 2. 960 what? Inches cubed. And increased by a scale factor of 3?
3,240.
Awesome. Okay, what happened to our original dimensions as we increased our dimensions by 2 and 3? What happened here? Nothing, right? So it all stays the same. Okay, what happens when you increase the perimeter by a scale factor of 2? How many times bigger? 2 times bigger. How many times bigger was the area? 4 times bigger. How many times bigger was the volume?
8 times.
Okay, what about by a scale factor of 3? How many times bigger for the perimeter?
3 times.
How many times bigger for the area?
9 times.
9 times. And the volume?
27.
Awesome. Okay, how did you guys get those values? The 2, 4, 8, 3, 9, 27. How did you get that?
Divided the increased one by the original.
So you divided the increased one by the original. That is what we call a scale factor. Okay, a scale factor, okay, is new over old. Okay, that is how you found those 2 times, 4 times, 8 times, etc. Okay, the way that I remember it is snow scale factor equals new over old. If that helps you, great. If it doesn't help you, no biggie. Okay, looking at the bigger picture here, okay, notice that we have a factor of 2. Okay, how do I get 2 times bigger? What exponent do I use to get 2? 2 to the what? How do I get from just 2, what exponent do I have to use here in order to get 2? 1. What exponent do I have to use here in order to get 4?
2.
What exponent do I have to use here in order to get 8?
3.
Very good. What exponent do I have to use with a base of 3 in order to get 3? To get 9?
2.
To get 27?
3.
Do you see the pattern?
Yes.
Okay, so you take your factor, and anything dealing with perimeter, height, anything that's just in your base unit, okay, is just to the first power of that factor. Anything that is area related, surface area, lateral surface area, total area, anything that's area related, okay, is always going to be that factor squared. Okay, so think about your units. When we find area for a square, rectangle, whatever, it's always inches squared or centimeters squared. Okay, so whatever exponent you use with your unit is what you use with your factor. Okay, so just like with volume, okay, volume, our units are centimeters cubed, inches cubed. So what do I have to do to my factor? I have to cube it. Okay, that is how we get these numbers. Okay, so if I were to use your notebook paper, I'm going to make you a little table. Okay, I'm telling you that our scale factor is 3. Okay, how do we find scale factor? What do we just write down? New over old, or snow, okay? I'm going to make a little table for you. Old, new. Okay, I'm going to give you a perimeter, an area, and a volume. Okay, my current perimeter is 20 inches. My current area is 108 inches squared. And my current volume is 220 inches cubed. Okay, with your elbow partner, I want you to tell me what my new perimeter, area, and volume would be with a scale factor of 3. Okay, so apply the rules that we just went over, and now find a new perimeter, area, and volume given those points. So think what you're going to have to do to that factor for area. What are you going to have to do to that factor for volume? Work with your elbow partner. It's too quiet if you're working together. Pardon? 108 inches squared. Alright, with my scale factor, I don't want the new value yet. I just want to hear what you multiplied your old value by. Okay, so if our scale factor is 3, what did you multiply 20 by? 3. What did you multiply 108 by? 9. What did you multiply 220 by? 27. So what was your new perimeter? 60 what? Inches. What's your new area? Very good. And your volume? Very good. Okay. On your test and on your review, you will have a little table like this, and you would have to work forwards and backwards, okay? Let's go back to this. Okay, does this make sense? Okay, that we're raising to a power here, 1, 2, and 3. Did everybody grasp that idea? Okay, so think about it. When you're dealing with perimeter, radius, a side length, a height, everything's always just in your base unit. Okay, so inches to the first power. Okay, anytime you're dealing with area, you've got inches squared, centimeters squared, meters squared, whatever. Okay, so you need to square your factor. Okay, and then with volume, your units are always cubed. So you need to cube your factor. Okay, turn the page. Alright, scale factor. Okay, scale factor, S for scale factor, S for your starting point. Okay, you're always going to start at your scale factor. Okay, so that is just A over B. Okay, just A over B. What do you think the area ratio might be? What do we have to do to area? Square it. So what do you think we're going to have to do to A over B? Square it. What is A over B squared? What does that look like? A squared over B squared. Okay, volume, what do you think that looks like? Very good. A cubed over B cubed. Okay, I'm going to switch up colors here. Alright, list me off things that are in just base units. When do we just use inches or centimeters or meters, whatever? What do we use that for? So yes, we do use it for scale factor, but give me examples. Like if I were to have a word problem and you were pulling information out, what could it be asking for? Perimeter? What else is do we measure with just inches, let's say? If I were to have inches, what could be measured in just inches? A side length. A height. A radius. Okay, so anytime in a word problem you see what's the perimeter ratio, or what's the side length ratio, or what's the height ratio, the radius ratio, any of those sort of terminology, okay, you are using just scale factor. Okay, so these would be our base units. Okay, I'm just going to use inches for example. Okay, so you're just in inches. Okay, now let's talk about area ratio. Okay, your units here would be something that is being squared. What kind of things are squared? Area, what else? What other types of area? What other types of area do we find in math? Surface area, and then there's one more that I can think of. What's that? Lateral. Okay, so again, if you have word problems, think what is the area ratio, or what is the surface area ratio, or the lateral area ratio. You're looking at area ratio. Okay, volume is just volume. I don't have any special things for that. Okay, but we are in what kind of units? Inches cubed or units cubed. Okay, so let's look at this table. I lied. We're going to fill in the hint first. Okay, your hint. Always reduce scale factor to simplest form first. So your calculator is going to be your best friend if, say, simplifying fractions isn't your favorite thing. Okay, there's a way to do it on the calculator, and I'll show you in a second. Okay, row 1 of our table. Okay, we've got a scale factor of 2/3. In order to get to area ratio, what do we have to do to A over B? Square it. Am I squaring A?
Yes.
Am I squaring B?
Yes.
Yes. I don't just square one of them. I have to square both of them. Okay, so what is 2/3 squared?
4/9.
Very good. 4/9. Okay, when I move to the right, to the volume ratio, I have to go back to my starting point, which is what? What's my starting point? 2/3. Okay, so scale factor starts with a S, starts with a S. Anytime you're filling out a ratio, you have to start with scale factor. Okay, you can't go cube area ratio. Okay, you have to cube your scale factor. Okay, so let's cube 2/3. And feel free to use your calculator if you don't know these off the top of your head, even though you should. Okay, what is 2/3 cubed? 8 over what? 27. 3 times 3 times 3. Okay. Line 2, what do you notice? We don't have a scale factor. Okay, how do you think we can work backwards? Okay, so the first thing that you're always going to look for, okay, are we simplified? Is 4/25 simplified? Yes. If you didn't know, you could type it in your calculator. You say 4 divided by 25. and then you would press math and the fraction button. And if you get a smaller fraction than 4/25, then it could have been reduced more. If you just get 4/25 again, then it's already simplified. Okay, so how could we get from 4/25 to scale factor? Square root. So we're going to take the opposite. What is the square root of 4/25? 2/5. Very good. Okay, how am I going to find the volume ratio? Cube what? 2/5. What is 2 cubed? 8, and 5 cubed is 125. Questions so far? Okay, now we're at volume ratio. Is 27/64 simplified? Yes. Okay, so last time we took the square root to get to scale factor. How are we going to go now? Cubed root. Are we going to cube root to get the area ratio? No, it's going to take us all the way back to the beginning at scale factor. Okay, so we're taking cubed root this time. Do you know how to find that in your calculator? I have to refresh myself. Math and the number 4. Okay, and then you would type in 27. What's the cubed root of 27? 3. What's the cubed root of 64?
4.
Okay, how am I going to fill in area ratio? You're squaring the scale factor. Very good. And what's 3/4 squared? 9/16. Okay, after filling in that table, okay, what do you think if somebody were to have made a mistake on this table, where do you think it would have been?
Use the volume and then write the area.
Okay, so solving for the wrong box. Okay, what else? Okay. Okay, they could have squared the area ratio. What else?
They would have forgotten to simplify the fraction and area.
Very good. Okay, that's the thing that people forget the absolute most. Whatever you are given, you have got to make sure it is simplified. Okay? Simplify, simplify, simplify. Just like scale factor starts with an S, simplify starts with an S, and start starts with an S. All three of those S's need to be your first thing. Simplify, start, scale factor. Okay? What else do you think? Anything else that anybody can think of? The only other thing that I could think of was just making sure you start with scale factor. Okay, let's look at the practice. This is where you're going to use your highlighters or markers or whatever you have. Okay, two rectangular prisms are similar. The small rectangular prism's length is 4 inches. The large rectangular prism's length is 19 inches. I guess I should have used 2 different colors there, but I just have one. Okay, the small rectangular prism's volume is 24 inches cubed. What is the larger rectangular prism's volume? Whoa, a lot of words. Okay, what 2 objects do we have here? Small rectangular prism and a large rectangular prism. Okay, to start off, you're always going to set up your ratio. Would y'all like to do small over large or large over small? Sweet, that's what I would do too, just because it's listed in that order. Small over large. Okay, we currently have the prism length is 4 inches for the small and 19 inches for the larger one. Okay, so we have 4 inches for the small, 19 inches for the large. Are we in area ratio, volume ratio, or scale factor? How do you know that we're in scale factor? Our units aren't squared and they aren't cubed. Okay, so we have to be in scale factor. Okay, so now I know we're in scale factor. What would be my next step? Make sure it's simplified. Okay, so before we move on, are we simplified? Is 4 over 19 simplified? Awesome. Okay, now it says the small rectangular prism's volume is 24, and we want to figure out the larger one. Okay, how are we going to get the ratio for our volume? Very good. We have to get our scale factor cubed in order to see our volume ratio. Okay, so what is 4 cubed? 64. What is 19 cubed? 6,859. Okay, so now I have 64 over 6,859. Okay, how do you suppose that I'm going to solve for the larger rectangular prism? I know the ratio it has to be, and I know the volume of my small one. How am I going to solve for my larger one? So if my small one's 24, and I need to know my larger one, how could I solve this? Very good. Cross multiply and divide. So we have 64x equals, I have no idea, 6,859 times 24, what do we get? 164,616. Okay, divide that, and what do you get as the volume? 2,572.4. Okay, what do we have? Volume of the larger, so what do my units need to be? Inches cubed. Units is another area that people will make a lot of mistakes. 1, they won't even give them. 2, they'll just leave it in inches. Okay? So make sure you're using the appropriate units. Go back to what the question is asking for. If it's volume, make sure your inches are cubed. If it's area, make sure that they are squared. If it's scale factor, make sure that it's just inches, base units. Okay, so what was our first step that we had to do? Scale factor. What if I was given area first? Very good. So do you notice that even if I were to have been given area first, I have to get to scale factor in order to start. Okay, so remember that. I'm sure there's going to be a question on the next one. Here we go. What is the volume ratio of 2 squares with areas of 225 meters squared and 400 meters squared? And we are looking for volume. So what are we currently in? Area. In order to get to volume, where do I have to go first? Scale factor. And then from scale factor, I can go to what? Volume. Okay. 225 over 400. Okay. What do I need to do to that before I go to scale factor? Simplify. Okay, so no matter what ratio you are in, you always simplify. Okay, so 225 over 400 simplifies to what? 9 over 16. Okay, so a lot smaller number and a lot easier to work with. 225 over 400?
Never mind.
It's okay. Okay, so now I'm at 9/16. How do I get to scale factor? Square root. Okay? What is the square root of 9/16? 3 over 4. Okay. Now we are at home. Base. Start. Okay, how are we going to get to volume? Cube it. What is 3/4 cubed? 27 over 64. Okay, are we done? M cubed. If you want to put units, you can, but since we're just talking about ratio, you're technically done. It is just 27 over 64. I mean, it's not necessarily proper to put the units, just because you're talking about a ratio. I mean, I wouldn't count off because that would be a little bit rude, but it's definitely not proper. Questions on number 2? Okay. I want you guys to do number 3 on your own. What do you think happens to pi when you put a pi in the numerator and a pi in the denominator? It what? It just cancels out. Okay, so anytime you have pi over pi, that's like saying 1 over 1. It's the same exact factor, so you can just cancel it. Okay, so work with your table on number 3. Find the ratio of the radii, which is just a fancy word for radius. Plural.
I didn't even tell them I should have. I told them simply, and they were doing it. And there was one that like 50. Yeah, we do. You can do it. It doesn't matter. Usually, and they were saying. People knew it, but does everybody know how to check to see if a fraction is simplified? Yeah. Okay, well just for those of you who don't, okay, type in, so for example it was 1024 over 54. So type it in the calculator, 1024 divided by 54, okay, and you'll get some decimal and I don't know what it is. Okay, then you press math, the number 1, and enter. Okay, if it is not reduced, it will reduce it for you. If it is reduced, you will get the exact same fraction that you put in. Got it? Got it. Cool. Do we need another minute or so, or are we good? Good question? Yeah. I would think that.
fraction? 1,024 pi over 54 pi, and the pi's canceled, like I said. Okay. Then what do you have to do? Simplify. If you switched it and you put 54 over 1,024, that's fine. Okay, you just have to be consistent. Okay, so say there was more to this problem, you would just want to make sure that you use the small over the large the entire time. Okay. Simplified, what did you get? 512 over 27. Okay, then what do we have to do? Why? Very good. We have to get to scale factor first. Okay, so cubed root. What is 512? What is the cubed root of 512? 8. Cubed root of 27? Okay, so how do we find the ratio of the radii? Why? It's not squared or anything. When we measure our radius, it's just inches, centimeters, whatever. Okay, so 8/3 was the answer. Questions on number 3? Raise your hand if you forgot to simplify first. Okay, so I'm sure it's more than just you guys. Okay, that's the biggest mistake that we make, is just not simplifying first. You can take the cubed root of these numbers, but again, your answer is not going to be in simplest form. So make sure you simplify first. Okay, number 4. Okay, the cones to the right are similar. What is the ratio of the height of the larger cone to the height of the smaller cone? What's the height of the larger cone? 12. What's the height of the smaller cone? 2.5. Interesting. Why do you say it's 2.5?
It's the perpendicular line to the base.
Don't you think it would be over like the dotted height like it was for the larger one?
Well, no, because if you did 4, then that would be the ratio of 16. That's, just because it's sideways doesn't mean that you choose something.
Okay, that was just a trick question, but it is actually not the height. Okay, 2.5 is what we call a slant height, and we're going to have an entire unit and lesson over it later on. Okay, but in order to find the height, okay, there's a little right triangle that you can make with the radius, the true height, and your slant height. Okay, so there's a little right triangle there that you can make. Okay, what is my radius? 2. So I'm going to redraw my triangle out here. My radius is 2. Okay, what's my slant height? 2.5. Okay, so I need to solve for my height. Is my height a leg or a hypotenuse? It's a leg. Okay, so should I be solving for C? No, I need to solve for A or B. Okay, so I have 2 squared plus B squared equals 2.5 squared. Okay, so type away at your calculator. What's 2.5 squared? Thanks. So subtract 4 from both sides. You have B squared equals 2.25. Square root. What is B? 3. 1.5? Okay. Square root of 2.25, it should be 1.5. 1.5 what? Meters. Okay, so now we know our height is 1.5 meters. Alright, it says, larger cone to smaller cone. So that tells you the order of which you need to write your numbers. Larger to smaller. So larger over smaller. Okay, so currently, when I'm referencing height, okay, what ratio am I in? Scale factor. Okay, so I have 12 over 1.5. Type that in your calculator and see if it's simplified. Very good. So it's just 8 over 1. Okay, so it says to find the ratio of their surface areas. What do I have to do? Square it. Square what? 8 over 1. What is 8 over 1 squared? 64 over 1. Okay, it is important that you leave it as a fraction. Okay, if you just say 64, okay, 64 to what? Or 64 what? Okay, so make sure you leave it as a ratio. A ratio requires two numbers. Okay, so leave it in a fraction form. Alright. Number 5, two similar pyramids have volumes of 3 inches cubed and 375 inches cubed. Find the ratios of the slant height, the base areas, and the surface areas. Okay, before we start solving, okay, tell me what ratio is which. A is what? Slant height. So something like 2.5. What are we in? Scale factor. Okay. The base areas, what are we going to be in? Area ratio. Surface areas. Area ratio. Okay, where are we currently? Volume. Okay, so we have our volume ratio, which is 3 over 375. Is that simplified? No? What does it simplify to? 1 over 125. Okay, then what? Is that scale factor 1 over 125? How do we find the scale factor? Cubed root. So I'm so glad that you guys said yes, because that is another mistake people make. They simplify, but then they forget to cube root or square root. Okay? Make sure that you go to scale factor all the way. Okay, what is the cubed root of 1 over 125? 1/5. So the cubed root of 1 is 3, the cubed root of 1 is 1, the cubed root of 125 is 5. Okay, so that's technically this part that we just did, because we got to scale factor. Okay, how are we going to go from scale factor to area? Squared. 1/5 squared is what? 1/25. Okay, how do I get to surface area? How do I find this ratio? Same thing, squared.
How does the slant height relate to a scale factor?
Because it's just in base units.
Okay.
So it would be like a side length or a radius or the perimeter. It's just in your regular unit.
Okay.
Okay. Try number 6 on your own. Try number 6 on your own. So start with solving for the height of the larger cone, or larger prism.